that I have never been to that part of India.
Yeah, this is Himachal Pradesh.
Himachal Pradesh, yes, I see and have read about Himachal Pradesh, and it's just beautiful.
I'm actually sitting in the foothills of the Himalaya.
Yes, it must be cold.
No, it is summertime and the temperature is very high, 36 or so in the daytime. But even the mornings are a bit pleasant. So
yes, yeah.
So if everything is ready, Keshav and Pradesh, we can start.
Yes. Okay. So, Engineer Shravant, you can start the proceedings.
Yes, sir. So, ladies and gentlemen, good morning and thank you for standing by. I'm Shravant, working as scientist in Environmental Technology Division, CSIR-NIIST. In the first place, Dr. A. Ajay Ghosh, Director, CSIR-NIIST. Today's keynote speaker, along with Professor Ravi Naidu, Founding Director of Global Center for Environmental Remediation, the University of Newcastle, Australia. Senior scientists, my dear colleagues, students and participants, a warm welcome to the World Environment Day lecture on the polluted earth, a dirty secret laid bare. This program is being organized by the Environment Technology Division, CSIR-NIIST, and we here are currently working on 3 core areas, that is environmental cleanup technologies, environmental management services, and Center for Excellence Dioxin Research Facility. So as you all are aware that the World Environment Day is celebrated annually on June 5th, led by the United Nations since 1973. This year 2022 will be remembered as the watershed moment in the history of the global environmental community. It has been 50 years since the 1972 United Nations Conference on the Human Environment, widely regarded as the first international environmental meeting took place. This year's theme is #OnlyOneEarth, which calls for the collective transformative action on the global scale to celebrate, protect, and restore our planet. This event is also being live streamed on CSIR-NIIST YouTube official channel. The questions will be taken at the end of the session, and participants can kindly raise your hand or post your question in the chat box of the MS Teams. Those who are attending via YouTube can post your questions in the comment section. So to begin with, may I now invite our director, Dr. A. Ajay Ghosh, to kindly deliver the welcome address. Over to you, sir.
Thank you, Shravant. Very good morning to all of you. Professor Ravi Naidu, Dr. Pradesh, my dear colleagues at CSIR-NIIST, other invitee students, ladies and gentlemen. A very, very warm welcome to the national, or I should say Global Environmental Day celebration. As Shravant has already briefed, it is the initiative of the National Environmental Protection Agency to initiate such a program for the protection of the Mother Universe. It is a global celebration and a global activity, and as part of this program, we, the country as a whole, celebrate. Actually, it was on June 5th yesterday, and being a Sunday, in many places probably the celebration may be going on today. So we also, as Shravant indicated, we also have an environmental technology division in the institute as part of our interdisciplinary activities. So in the division, we take care of many activities related to environmental remediation, environmental impact assessment, waste management, both solid and liquid, municipal waste, and we also provide viable technological solutions to the industrial need. But as part of all these activities, we also create a lot of uneasiness to the environment, and many a times this is beyond the limit, and therefore it is necessary to take care of and take necessary remedial measures to minimize this impact. You know, the national economy or the global economy is very much dependent upon the developmental activities. And when we say developmental activities, it is nothing but science and technology progress. And as a consequence, industries, benefit out of the science and technology industries prosper, the economy prosper. But as a result of all this, we have a lot of adverse impact on the environment. So it is a collective responsibility, but particularly the scientific community and the governance, to take care of necessary measures time to time to take care of these kind of adverse impact and suggest remedial measures to reduce the impact. And we are all now victims of the global warming. As a part of these developments, we pollute the water bodies, we pollute the air, we destroy the flora and fauna. Very significant reduction in the forest, globally. And the climate is changing abruptly in many places. Many of the cities and countries which are below the sea level are under the threat of flood and submerging to the ocean. So due to all these environmental issues, the life in the earth is under threat. So, a lot of people die in the polluted cities due to the respiratory problems, so many other health issues. So there are so many issues. Even in our own state, the small state in India, we are witnessing heavy flood for the last 2-3 years. And our air is getting polluted. There are massive landslides. A lot of people have lost their life and properties. So this is going to only, climate due to the last, environmental impact, especially last 2-3 years, we had heavy flood. A lot of people lost their life and property, and massive landslide happening in many of our, high-range areas. So some of our cities, like for example, the city called Cochin is under threat for, flood, and the water level is rising. So all of you are aware of all these, current situation and the future consequences. Therefore, creation of an awareness is the most important thing. Not only creating awareness to the common man, but also creating awareness within the scientific community and the governance within politicians. All are important. So massive actions are required, and so this is a global, massive action. But see, doing something annually is not enough, and it is nothing. Every day there should be something on this, related to environmental issues. There should be educational programs, there should be awareness programs, and scientists, when design their programs, developmental programs, should seriously consider the environmental impact, the threat the programs are posing to the environment, the pollution. So it is our responsibility to find out viable scientific solutions when we design, technologies and processes. So today, to talk about all this, we have a very great personality with us, who is a very active scientist in the area of environmental remediations, environmental protections, Dr. Ravi Naidu, and we are all looking forward to listen to him. Therefore, I am not taking much time. So I request my colleague, Dr. Keshav Chandran, to introduce the distinguished speaker to the audience, and then you may invite Professor Naidu for his lecture. So, Professor Naidu, I may have to leave in between for another meeting, so kindly excuse me if I am not staying for your whole talk. But probably I will listen to your, I think you are recording it, Keshav Chandran?
Yes, it's available.
Because I want to, listen to his entire talk maybe sometimes later if I miss it.
Sure,
today.
we will share it
So
to you.
once again, on behalf of all my colleagues and all the participants, I extend a very, very warm welcome to Professor Naidu, and also on behalf of my colleagues, I thank you for accepting our invitation. So
thank you very much.
Yeah, thank you.
Thank you, sir. Thank you so much for that inspiring welcome address and related to the celebrations on World Environment Day. Once again, good morning to all of you, and it's a proud privilege for me to introduce to all about the eminent speaker on the occasion of World Environment Day 2022, Laureate Professor Ravi Naidu. Professor Ravi is CEO and Managing Director of CRC Australia, and founding director of Global Center for Environmental Remediation at University of Newcastle, Australia. Professor Ravi has done extensive research in the domain of environmental contamination and remediation, with a special emphasis to local, national, and global level, which is currently the contemporary research area in the environmental sciences. His in situ remediation research mostly focused on now widely accepted in quotes risk-based approach to managing contaminated sites. Again, a currently very important contemporary research activity going on globally in this area. Professor Ravi received a PhD and DSc in environmental sciences from Massey University, New Zealand. He is elected from several prestigious academies, including Fellow of Royal Society of Chemistry, Fellow of Royal Australian Chemical Institute, Fellow of Soil Science Society of America, European Academy of Sciences and Arts, Royal Australian Chemical Sciences and Engineering, Indian Academy of Agricultural Sciences, Royal Society of New Zealand, and the list goes on, but because of paucity of time, I am restricting there. He has been chairman of several international committees and former president of International Society on Trace Element Biogeochemistry. Professor Ravi Naidu has authored or co-authored over 1,000 research articles, technical publications, 13 patents, and co-editing 16 books, and over 100 book chapters in the field of soil and environmental sciences. Professor Ravi has supervised over 50 PhD students. He has recently received Doctorate of Science from Tamil Nadu Agriculture University for his outstanding contribution to agriculture Sciences. Also won the Banksia Sustainability Award, very prestigious, recognizing his contribution towards environmental sustainability. I know this is a very brief introduction for eminent personality like Professor Naidu, but due to paucity of time and the proceedings, I am concluding as a brief introduction to all of you. I may now request Laureate Professor Ravi Naidu to take over and have the World Environment Day address to all of you. Thank you, sir. And over to you, Professor Ravi Naidu, sir. You can now upload your slides.
Thank you very much, Dr. Keshav Chandran, for your warm introduction, and also to you, Dr. Ajay Ghosh, Director, for the introduction to this forum. Both of you have summed up really well about the environment. And what I'm going to do today is provide a general overview of the environment. So talk about the soils, the functions of soils, and what pollutants do to the soils. Why the title, The Polluted Earth, Our Dirty Secret Laid Bare. I also want to thank Dr. Prasidh for writing to me and inviting me for today's presentation. Had it been yesterday, I would have had to say no, because I was in another forum yesterday from Indian Council of Agricultural Research, where the presentation was on a different topic, but yet about the environment as well. So let me just see whether I can. So do you see my presentation?
Yes, yes.
Yes. I'll just go to slideshow.
Yeah.
Do you see the slideshow now?
Yes, it's perfect now.
Yes, thank you very much again for the introduction. As the title says, I am going to take us through the polluted earth and why our dirty secret laid bare. I also recognize CRC Care, which I had led since when it was first established in 2005, and CRC Care is the Australian Centre of Excellence that focuses on environmental contamination assessment and remediation of the environment. It brings together Australian defence, mining companies, water industries, petroleum industries. They all bring to us the environmental contamination challenges they're posed with, and our task is to come up with solutions for those problems. The Global Centre for Environmental Remediation is something that I established at the University of Newcastle, and that is the engine house for CRC Care, where we do all of our research. So a brief outline on World Environment Day, Mother Earth, a little bit about that, the chemical pollutants on Earth, how it impacts human and environmental health, risk implications, and why our dirty secret laid bare, and a little bit about Global Care Alliance, which are launched in 2013. World Environment Day, as you heard from our director, sir, this was established in 1972 by the UN General Assembly and recognized and celebrated annually on 5th June, which was yesterday, and a lot of people are celebrating this today as well. And this is the principal vehicle for UN to encourage awareness and action for the protection of the environment. Theme this year is Only One Earth. Just ask yourself this question: what if you destroy this Earth? There's no other place for us. And therefore, every attempt must be made to see how we ensure sustainability of our environment and hence Earth. There is no other material, as I say here, as unique as Mother Earth. And if you take, for example, a teaspoonful of soil and look under the microscope, you'll see it teeming with activities. There are microbes there, fungi, for example. You could see perhaps algae. It's full of activities. A dead soil is one, for example, where you won't see these activities. And of course, these microbes that you see, microbial activities, they're also about biogeochemical cycling and hence soil health as well. It is the medium for plant growth, as I take you through later, that it filters our water. It's a critical component of the global natural system, and it's a vital contributor to human well-being as well. So if you look at some of the soil functions, for example, the soil functions and it's a living ecosystem. It's all about biogeochemical cycling, as I said, neutron cycling and storage of carbon dioxide, helps sequester carbon dioxide. It's an ecosystem for soil organisms. And if you look at the microcosm in there, as I said, you will see it teeming with activities. It also filters water. It helps us store water and also helps purify water as well. And of course, it is all about food security as well. Just imagine if you do anything that impacts functioning of the soil, how it's going to impact biogeochemical cycling, in turn, the ecosystem processes. That's all about food security. Now, when we look at arable land and food security, you'll see from this figure here on the left-hand side, the world population has increased in the last 60 years from about 3 billion to 9 billion. It will be 9 billion by 2050. That will be a massive increase in the number of people. And coupled with that, when you look at arable land per capita, you will see, as from the figure, that with time, with the increase of number of people, the arable land hectare in use per person keeps declining, which means that we keep clearing land and keep converting that into farmland or for real estate. And in doing so, with the number of people, the arable land per capita keeps declining. And here we have developed countries and also developing countries, and the mean that you see there. It's not leveling off, it keeps declining. When you put all of that together, takes us to soil degradation. It could be by physical, biological means, or chemical. I'm not going to focus on physical and biological, but I'll look at chemical in my presentation. Chemical degradation is impacted through 36 million hectares of land, and a lot of that degradation is linked to heavy metals, radionuclides, and organics, which is more than 40 to 60% of this impact that we see there. And hence the reason why the UN FAO has focused on the farmland and particularly contaminants associated with farmland, and hence the launch of the International Soil Pollution Network to see how we could help different countries assess, monitor, and clean contamination of our farmland. I'll touch on that later. But look at the human impact on environment. We start with this virgin land with lots of trees, for example, and organic matter content that could be anywhere between 160 to 250 tons of carbon per hectare. And then when you convert it into farmland, over time, carbon content of soils decrease to almost 10 tons carbon per hectare. This is in heavily disturbed soils. And of course, this disturbance is all about trying to convert virgin forest land into farmland. And during the process, we are not returning organic matter to soils. Actually, every time you till land, you are mineralizing organic carbon, and therefore the soil's ability to sequester carbon also starts to decline. And likewise, when you have contaminants, it impacts microbial activities as well. Now, farming is all about sustainable crop productivity, and for that, we often tend to use fertilizers, and there's always excessive use of fertilizers, excessive use of pesticides, and the sources of nutrients. Often we go to biosolids or sludge from municipal effluent treatment process. And the expansion of land, as I mentioned, means converting virgin land into arable land, and sometimes hills as well, which leads to massive erosion. And of course, mining means the overburdened soils are often lost. So all farms are impacted by pollutants, be it metal pollutants or pesticides, which is organic pollutants, and yet their presence is not recognized until adverse impacts are seen, and I'll take you through some of the adverse impacts shortly. Now, here's the money talks. presence of pollutants is recognized only after rejection of trade. For example, we didn't recognize the presence of cadmium in our farmland until such time that the shipment of wheat was rejected by Europe because of elevated level of cadmium. It is the trade which led us to look at the levels of cadmium in our farmland and then to come up with management strategies that minimizes the transfer of cadmium from soil into wheat crops. You can't remove it, but you have to manage it while still present there. Soil was always taken for granted as of high purity. Equally, beef meat was rejected by US in 1990s and highlighting pesticides exceeding threshold safe levels. And again, we have to go back and look at how we are managing pesticides as well. The presence of cadmium was first recorded after poisoning of people in Japan. There was an industry factory, they were disposing waste onto paddy field, and from the waste was cadmium that was taken up by rice, for example. Rice was consumed by people, and that was the outcome. Nobody bothered about cadmium until such time that its impact, adverse impact on human was recognized. Equally, the selenium in soils, particularly wheat to human, selenium in soils to pasture to animals, and this was only made public only after recognition of poisoning. A tendency is always to maintain silence, and here you have people who've been poisoned by the presence of excess selenium, and animals were poisoned as well. So what I'm trying to bring to attention is that we don't talk about the presence of pollutants in soil. We only start talking about it once it impacts us. And sometimes we want to remain quiet as well. And contaminated sites that in the urban environment, they're always very highly contaminated. And the tendency by decision makers is to maintain absolute confidentiality, because once people come to know that your house next to you is contaminated, there's social issues, there's stigma, because property value drops, land value drops, and therefore the tendency is always to maintain silence. But the class actions that we see in US, for example, and indeed Australia as well, are now forcing regulatory jurisdictions and owners of contaminated sites to communicate to affected communities as well. And therefore, class actions and also trade has forced us to bring to attention of the community the presence of contaminants in soil environment. And of course, Earth is now affected by more than 300,000 synthetic chemicals. There's the landfills that we see. Every country has landfills. Most countries have landfills which are not engineered properly, and therefore landfills generate leachates. Leachates are filtering through soil and reaching groundwater. Water is contaminated. Here you can see dye, for instance. There's emission, for example, effluent. We have hazardous waste. We have electronic waste, for example, textile dyes again here, and indeed air pollution. So no matter which direction you look at, which country you look at, there's always a source of pollution. In developing countries, if you do not have industries, in small countries, you'll have landfills, for example, but most countries would have industries. And there was a time you're disposing industrial waste onto land and water bodies. And you can ask this question in India, because there are so many places where we have been disposing, for example, tannery waste. And there is a river in Chennai, which is almost fully polluted now, and groundwater, well water, some of them have the color of hexavalent chromium, with the chromium having leached into groundwater. Just a list of pesticides, herbicides, for example, most, if not all of them, are found in soils. This is a mere drop in the ocean of all known and unknown chemicals, because every year we are adding, every day we are generating at least 3 new synthetic chemicals, which means very soon we'll go exceed well over 300,000 synthetic chemicals. There are quite a number of different sources of pollutants. There's poor agricultural practices. There's solid waste management improper, because you're using, for example, municipal waste some of the industrial waste that could potentially have nutrients without recognizing the low doses of toxins, unsafe storage of hazardous chemicals. Sometimes it leaks, for example, mismanaged landfills, talked about, and uncontrolled dumping of waste from household industrial waste. This is a really nice report from UN. Now, the pollutants that I was talking about, there are two different sources. One is point sources, and point sources are very highly contaminated sites. And these are small areas, but very high level of contamination. And then we have non-point sources, which we sometimes refer to as diffuse contamination. Diffuse contamination could be air pollution, for example. It could be pesticides that we have used, for instance, and those pesticides, for example, are spread in low concentrations in large areas of the soil. Equally, cadmium, for example, that that's on our farmland, low doses of cadmium, which is spread across our farm. And the challenge between non-point and point sources is that when you have to clean up with point sources, you have to clean up small areas, though you have to manage groundwater contamination as well. With non-point sources, for example, very large areas, low dose of contaminants. Whereas in point sources, you could dig the soil and take it somewhere to treat. But for farmland, for example, you can't move that soil. That's highly low contamination. The challenge with low contamination is that plants bioaccumulate and often exceed threshold values. So we can only manage the presence of these in farmland such that we are not allowing it to leak. We are not allowing it to be taken up by plants and ensuring crop quality. Now, if we look at human emissions, for example, the latest reading is that we are generating more than 250 gigatons of human emissions, of which 30 million tons is in industrial chemicals and pesticides, 100 million, 50 million of N, 11 million of P, and a very large volume of hazardous waste, very large volume of e-waste, and 15 billion tons of coal, oil, and gas emissions. So if you see the large emissions, now this is what contributes to climate change. Climate change hasn't occurred. It is what we are doing that has led to climate change. You will manage this, climate change impact will start to decline. And that's one reason why I'm saying that in its scale and global implications, pollutants, human emissions, is the most underrated, underinvestigated, and poorly understood of all the essential risks facing humans in the 21st century. Now, the impact of chemical pollutions is larger than that of climate change because of these very large emissions that we see. And the impact of climate change is not because of anything else other than what we have done to our Earth. Now, pollution crisis threats to human health. Now, the most recent report that we have from Lancet Commission on pollution and health and human health estimates told that there are 9 million premature deaths, whereas while the US National Institute of Health placed the figures as high as 13 million last year. We published an article in 2021, we referred to this, but also note the WHO report that every year air pollution leads to nearly 7 to 8 million deaths, and another 4 to 5 million are from direct exposure to pollutants. If you look at humans, for example, we inhale, we eat food, and if the quality of food is one that has pollutants, for example, we are ingesting that on a daily basis. The risk is proportional to duration of exposure. And when we keep exposing ourselves, it's impacting our vital organs. That's where pollutants go and reside, for example. It gets into our blood serum as well. You don't feel anything until it really impacts you when it's a very painful death. And that's what you don't want. Yet people, even medical fraternity, they don't look at prevention. They look at cure only. Our governments also don't look at prevention. We look at cure. And so until such time that we start considering pollution as a major threat to humanity, we will not be able to handle this challenge. This just shows the threats to human health. Different industries over here, how they are ranked. They rank from disability adjusted life years and the potential pollutants associated with that. And emphasis is now growing on previously underestimated soil pollution. So there is a huge challenge ahead of us. Ask yourself this question: do we have these industries in your country? And if you have, what impact it is having on human life, for example. And here you can see I've worked in 10 with 10 impacted sites in India, and I've also worked in Bangladesh on arsenic. But look at all of these industries. I'm pretty certain you'll find these in India as well. Soil pollution, therefore, is a hidden reality, and the toxins beneath our feet are posing significant threat, not just to the soil ecosystem and hence food security, but human health as well. So here's a volume of report that the Food FAO had produced, a global assessment of soil pollution, and we contributed a report on Southeast Asia region. This I believe could be downloaded, and I'll see if I can look up the link, and if anybody who needs it, let me know and I'll send that to you as well. This another report here states that 1/3 of global air pollution deaths in Asia, deaths that occur are in Asia Pacific. And look at the air pollution in India, for example, in China, for example, in other Asian countries, air pollution is massive. It's not just killing people, but it's impacting babies, unborn babies. And here you can see these chapters that we have, and I'll see if I can send you the link on the status of soil pollution in Asia and the Pacific region. So pollution crisis is a global peril, as we say here. I did speak about the number of pollutant chemicals that are released on a daily basis and what we already have. I talked about the number of people who die from exposure to pollutants. And one thing I wanted to bring to your attention is that the publication in China, where almost 1/5 of China's soil is polluted. Very brave of the scientists to do this work and publish it. And that's one reason why FAO has got a mission now to see whether we can come up with a map of pollution map of each country. And therefore I would be as I have been appointed as the chair of the International Network on Soil Pollution, I'll be connecting with you to see how we could jointly work to map areas of farmlands where there might be elevated levels of pollutants and how we then work with the farmers to clean that. Lots of plastic debris in the ocean, and we produce and dispose of nearly 400 million tons of hazardous waste. And in many countries, we have drums and drums of these wastes that we are keeping, storing, but not remediating because we don't know how to remediate. And here I have the number of contaminated sites globally. This number goes up because a recent report suggests that there's 3 million potentially contaminated sites in Eastern Europe. It doesn't include the number of sites in African and South American countries. Put all of that, you're looking at 10 million. And we haven't remediated any more than 1% of these contaminated sites in 75 years since we've been doing that. Now, this is a very rich industry, remediation, because we are spending nearly 80 to 90 billion dollars per year. So I'll be looking at Indian scientists, particularly scientists and civil engineers, who could turn themselves into assessing and remediating contaminated sites. I won't go into the pathways of exposure from pollutants because we know from crops to human health, from water to human, for example, from pasture to animals to human, and the water that we drink to us. But I want to bring to attention that now it is well recognized that pollutants impact cognition and male fertility. Pollutants are impacting at gene level as well, and that 75% of babies born are already impacted. And therefore, if you take that into consideration, and also this other arrow here, the death, when you look at the number of people who die from different illnesses, including smoking, pollution far exceeds the deaths. And therefore, if you couple the way people are dying now with how it's impacting fertility, it's basically pointing finger in one direction only. Come 150, 250 years, humanity would be it would be at risk. And that's another reason why for future generations, we have to invest resources to prevent and clean up our environment as well. It's also impacting our sustainable development goals, quite a number of those. I won't go into these, but we did say that by 2030, sustainability is something that we'll work on. And if we do not start working on cleanup of the environment, we will not be able to deliver UNEP's sustainable goals. This here is an example of regional trend in Australia. And here, sorry about that, the chart is the other way around. But what I want you to not to worry about this internal figure, but I want you to look at this figure X, Y-axis and X-axis. One thing you'll see from here is that the largest volume of waste here is contaminated soils. And then we have biosolids, that's from the water treatment, and of course there's asbestos as well. Now, if we are not able to manage contamination of our soil, prevent further contamination, we will be ingesting contaminants through water, through food that we ingest, and ultimately it will also lead to significant impact on our health as well. I mentioned about the different sources of pollutants, agriculture, industrial activities, urban setting and geogenic sources. So I'm not going to spend too much time here, and nuclear activities. But I want to take us through what we call the impact of the critical zone. Critical zone is defined as a zone from the top of the trees all the way to groundwater. Now, when you look at top of the trees to groundwater, the air that we breathe, if you have any pollutants that volatilizes, for example, we'll breathe those pollutants, particularly if pesticides, for example, we'll breathe that. If pollutants come into contact with soil, this is about food security. Your soil is impacted and it impacts the very sensitive microbiota, and therefore it impacts the ecosystem services, particularly the ecosystem processes. Biogeochemical cycling is important. Impacted carbon sequestration is impacted, food security is impacted. If it leaches through the soil, it gets into groundwater, and groundwater is impacted. It's not static, it also moves, can take the pollutant to the riverine system or the ocean. So all in all, no matter which way we look at it, everything that we are doing, it is impacting critical zone. The reason why it's called critical zone, because it's all about our sustainability. It is sustaining the earth, sustaining services, clean water, productive soil, and balanced atmosphere as well. So I mentioned about the processes within the critical zone, the ecosystem processes that consequently supply products and that benefit society as well. And the undisturbed top centimeter is 160 to 250 tons of carbon. And as I mentioned earlier, tillage has led to about less than 10 tons of carbon per hectare. So benefits that are linked to critical zone, I mentioned earlier, it's food and fiber production, filters contaminants from runoff and groundwater discharge, transform nutrients for availability to ecosystems. It's also about carbon storage from the atmosphere. It's about preservation of Earth's terrestrial gene pool as well. And this is what is defined as ecosystem services. As mentioned earlier, here what you see is the soil is the first filter of the Earth's water. And as it passes through, it removes pollutants. But once it is saturated, it doesn't remove pollutants, gets into groundwater. And when it removes pollutants, that pollutants can be taken up by plants as well. So you might purify water that is getting into groundwater that we drink, but at the same time, the filtered soil might contain so much of pollutant that's taken up by plants as well. And so groundwater is a resource in need of protection. And if we do not ensure clean soil, groundwater will be impacted as well. So Costanza et al. In 1997 published an excellent paper in Nature on 17 ecosystem services, the benefits that people obtain from. These are provisioning, regulating, supporting, and cultural services. Now, all ecosystem services involve soil. And when you look at the ecosystem services provided by soil, supporting is the services necessary for the production of all other ecosystem services. So for provisioning, regulating, and cultural, we need these supporting ecosystem services, nutrients, soil formation, and primary production as well. When we get to provisioning, it's the products that we obtain from ecosystem. So we need the ecosystem processes that provides us food, fresh water, wood and fiber, and fuel. And pardon me, excuse me. Um, and here we're supporting and regulating. That's benefit obtained from regulation of ecosystem processes. So that's the benefit that we obtain. And then it's also cultural, which is non-material benefits, aesthetic, spiritual, educational, recreational. All of these are interlinked to each other. If you look at the links between provisioning, regulating, and cultural, the link to constituents of our well-being as well. Won't spend too much time there, but there is always a trade-off amongst ecosystem services. It's almost a rule because when we convert forest to farmland, it is always to increase food supply. And these days, we are also going back from farmland into forest. People are starting to plant trees because of climate change as well. So there's always a trade-off of something, and it's seen here. All of these do include soil as well. So when we look at global ecosystem services, it's estimated at an enormous US $33 trillion per year, which is almost, if you look at global GNP, it's just $18 trillion per year, and therefore ecosystem services is almost the double of that. Just imagine the pollutants impacting the biogeochemical cycling, ecosystem processes, what impact therefore it is having on ecosystem services from food security perspective is one example. So this figure here again shows that the world population is increasing. Will be 29 billion by 2050. And this increase in world population is and will continue to put pressure. It will require an increase in our capacity for infrastructure and also food and water, and that is going to worsen the situation. So we do need large investment, therefore, to ensure that our ecological infrastructure has the capacity to continue to produce. If we do not invest both in resources to train people, human resources, and at the same time, ability to clean our land as well. So impact of contaminants, the critical zone, from food chain perspective, every pathway, exposure pathway to human is impacted. Soil is impacted. When soil is impacted, crop quality is impacted, and human health can be impacted. Soil is impacted, food or pasture is impacted. Animal, for example,
Professor, you have gone.
Professor,
your mic is mute.
Can you?
Hello.
Okay, can you hear me now?
Yes.
So the critical zone is about food security, and impacting that, it impacts food security as well. So human impact on soils, just looking back, I spoke about deforestation, overpopulation, the generation of waste, for example, the impact from pollution, waste of natural resources. I won't touch on energy, but did discuss about land degradation that directly or indirectly impact soils as well. So here are some papers that we have also published where we have looked at fate of pollutants, with particularly the impact on soil properties and how it impacts climate change. And here's another one where there's some work done where people looked at not just pesticides, but also how it impacts biodiversity. And we said there's not just pesticides, all other pollutants impact biodiversity. The very sensitive microbiota will be gone. And if the concentration of contaminants increased, other microbiota can also be impacted, and as a consequence, biodiversity as well. But the extent of the impact can vary depending on the nature of soils. going from South India to Northern India, for example, soil types vary, organic carbon content.
Professor, you are again muted.
I don't touch that. So how the different soil types impact contaminants interact in different soil types, how these that they impact biodiversity is something which we still need to look at. Some countries are starting to do that. We are yet to do that. Let me just see if I can. So there are forces, consequences, and legacies. If you look at economic, for example, pollutants can impact production. Pollutants present in crops, for example, if you are exporting, trades will be impacted. There's cost of cleanup as well, and there's about employment. If we introduce polluter pays, for example, it helps as well. There's then social legal issues relating to pollutants as well, and there could be litigations in some countries. In our countries, people don't talk about that, but remain quiet. But just imagine a lot of the time, people who go out in the field and work, people who use pesticides, for example, people who don't know that the soil is polluted, the impact, particularly women, for example. And then to do all of the work on all of these, we do need science and technology, a detailed understanding, but large scale solution must be sought. Bioremediation is one approach, but it's not doesn't work for metal contaminants, for example. And we do need to look at what remediation technologies we can come on board and how do we predict risk as well. So a clean, healthy and productive environment requires a balanced goal. It's not just about science underpinning a technology, it's about economic forces, it's also about social legal frameworks. So going from an urban environment to a rural farming environment, social legal frameworks would be very different, economic force would be different, and therefore we have to combine all of these in coming up with sustainable solutions. So where we are now from solutions perspective, if we just look at waste, for instance, we are now talking about circular economy. We're talking about reduce, reuse, recycle. We talk about incineration and disposal, but not all of these work all the time. There's a lot more that we still need to do. So, but what's favorable is prevention, personal engagement, each household and community, but it's slow. We need to communicate to people, and visibility of the impact of pollutants is so important. And above all, regulatory and policy implementations. How can scientists work with regulators to make certain that the policy is underpinned by sound science? Otherwise, it will be very conservative policies. How do we get our citizens? There is a citizen science funding. How can we engage with citizens and work with them? And this is what I'm looking at from all of you as the chair of the most recently launched network. How can I work with all of you and the farmers to see whether we can map farming areas that have been impacted by pollutants, and what can we do to clean up our land? So past practices and current approaches might no longer be sufficient, and the question is, will they be sufficient? If you look at, for example, US EPA, US EPA said forever, we may keep saying that talking about the impact. At some stage, we have to accept the uncertainty and start repairing the damage that has been done. And to do that, you have to look at implementing measures. What do we implement? Evaluate vulnerability, identify what alternatives are there, and evaluate economics as well. And all of these do require science to underpin it. As scientists, sometimes we want to keep doing research, but as engineers, we always want to see how do we convert the solutions that we come up with into technologies. And therefore, scientists and engineers working together is the only way to come up with solutions for the problems that we see. So regional is a big factor. There's many developed countries in the Asia Pacific region. They implement legislation that prevents greater environmental pollution and provides guidance for soil remediation. But the key question is, we have these legislations. Do we work within the constraints of the legislation? Do we still see people disposing waste onto land. Most developing countries in the region are still struggling to cope with soil pollution, and for two reasons. One is we do not have sufficient capacity, human capacity to deal with this, so we need to train people. The second is money, because any cleanup requires investment, and therefore unless we get support from the government of the day, unless we get support from the industries that pollute, it will be very difficult to clean. There are many gaps that have been identified. We do not have a register of potentially contaminated sites in India and in many other countries. I mentioned about human capacity. We need to assess sites. We need to look at the source receptor pathways, create awareness, go down all the way to primary schools, to high school, to the universities. If we just focus on university graduates, we may not be, because almost every parent would like their children to be a doctor or an engineer.
Professor, you have again gone to mute. Hello?
Yes, I'm sorry,
yeah,
it automatically goes to mute for some reason.
It's okay, it's okay. Please go ahead.
Maybe there's a message that I should stop talking.
No.
So what I'm trying to say is that pollution is very complex in soils, and therefore it requires a multidisciplinary approach. And that's what I've done in this CRC that I have in my center. I've got civil engineers, chemical engineers, mathematical modelers, chemists, microbiologists, and physicists. They're all working together. So we need a global science policy body on chemicals and wastes. I have been pushing for this since 2013, and I need all of your support, because if you can support me with what I'm looking for, I'm pretty certain, particularly from your signatures, I'm pretty certain we can convince UNEP to come up with that policy as well. Why are dirty secrets laid bare? Because always there's a tendency to cover off anything relating to contamination. Contamination was only laid bare given shipment of beef unaccepted by USA. Otherwise, nobody would have been talking about pesticide contamination. We only started working on cadmium because cadmium-loaded rice was rejected by Europe, and hence we started working on cadmium. And of course, poisoning of farmers as well. I only started working on arsenic because thousands of people died from arsenic poisoning. When I started working on arsenic, nobody would give me any resources, and we only got resources after recognizing that arsenic is present and impacting people. And in selenium, the same thing, of course, air pollution as well. So here we have reached a stage where people are recognizing pollution as a serious challenge, and we need to see how we can now move forward and help clean up our environment. That brings me to what I have launched in 2013, Global Contamination Remediation Alliance, Global Care Alliance, and this recognizes the need for us to do something beyond Australia, because the scale is global. So we want to take the success of CRC Care, which is seen as one of the outstanding national centers of excellence in Australia with global connections, and we want to move it to a global platform and focus on developing countries as well as developed countries, and largely to train people so that we can minimize the exposure of humans and Earth's biosphere to anthropogenic chemical contamination from all sources. We can do that by educating consumers, industry, and governments. We can do that by sharing scientific knowledge and technologies. One second. We can also do that by developing and assisting the adoption of cost-efficient technologies to assess, clean up, or prevent contamination. And this will create value with beneficial uses for contaminated land, and of course prevent disease by fostering cleaner industry and contamination-free food as well. So Global Care is an international alliance of industry, leading scientific and government and community organizations. Free membership, and therefore I would love to have you join Global Care and jointly work with us to help clean up the environment. So we're looking at all stakeholders, be it researchers, be it regulatory bodies, be it industries. So if you can expand global care to industries in India as well, we'd love to have them on board. And we also organize forums that brings together researchers. As you know, the Indian Congress that I had, where lots of researchers came together, and we have the next one, which is run by Malaysian government in Malaysia. It's also an information exchange forum where people talk about solutions that they have and also challenges as well. And once, if we can launch global care in India as well, we can work together and see how we could transfer some of the knowledge that we have here to India as well. That brings me to the International Network on Soil Pollution that was launched on 22nd April this year. Pretty similar to what Global Care is, and I've been invited to chair this network. This network focuses on 6 main areas, and you can see those 6 main areas: mapping of soils, monitoring and regulating pollutants in the mapped soil, sustainability and remediation, clean food, for example, clean water, and then goes back to assessment. And I have a massive task to take this to as many countries as I can, and hence, Director Sir, I'll be looking at how I could work with you to take this to India as well. And with your support, we start to deliver some of these milestones that we have identified. So your help in delivering this would be so much appreciated. So in concluding remarks, almost all farm soils globally have at least low doses of toxic cadmium and pesticides. The challenge is that even though it's low doses, these can be bioaccumulated in plants and hence through plants can reach us. There's limited information available of the level of this contamination in farm soils in many countries. Contaminants impact the Earth's critical zone and hence soil productivity and crop quality. Regulations could play a central role managing introduction of new chemicals in the environment. And there is a need for an accord such as Paris climate change, but for soil pollutants. And I can send a link using which you could support me. And if you could support me, if I get 50,000 signatures, we can then try to see whether we can get this global initiative, which is so crucial. It's all about our future generations as well. So I'm just acknowledging my scientists who helped me prepare this. University of Newcastle, we are based, and CRC-Care, which is the National Center of Excellence as well. I want to take you through Cleanup 22 conference. I run this once every 2 years. So international speakers included Minister for Environment Singapore, Minister for Environment Malaysia as well, and many eminent peer individuals. This is run between 11 to 16 September 2022. Please see whether you can join me in Adelaide, and you can write to me in either of these 2 email addresses at crckare.com or at newcastle.edu.au. I'd be happy to provide you what you would like to provide me with for your research and also collaboration. With that, I would like to thank you all for your patience with me and for listening to my presentation. I'll be very pleased to answer any questions that you might have.
Thank you, sir. Thank you very much for your amazing pictorial presentation, stating how the unique Mother Earth is and how it is contaminated by various synthetic chemicals, the significance and presence of pollutants in the soil and the impact on the human environment. It is our pleasure to have you on this day while we are celebrating this World Environment Day. And now we may take up questions from the participants. Those who have questions can raise their hand or post it in the chat box. Already we have some 3 questions. So Professor, what is the difference you have observed in the environmental policies and its implementation in
Sorry, come again with that question. Difference in environmental policies, and I've missed the last couple of words.
I'm coming once more, sir. What is the difference you have observed in the environmental policies and its implementation in developed and developing countries?
That's a really good question, a tough question as well. A good question because it's about policies. A tough question because depending on which country you are in, the regulatory jurisdictions, the intent and penalties could vary quite a lot. I'll give an example. For instance, in Australia, there was one industry, as I said, accidentally somebody disposed contaminated liquid into the sewer system, and this company was fined $250,000. And even if people drop waste, for example, there's a massive fine.
You got muted, please unmute.
You can take waste to prescribed landfills, but you got to get permission from appropriate agencies. So that's what I see in some countries. For example, you might have all the policies, but people to work within the policies, it can be quite a challenge. So there's a huge difference that I see in different countries. But clearly in developed countries like Australia and New Zealand, for instance, been in the US, I've been to UK as well, I've been to European countries as well. The penalty is massive, and therefore people work within the constraints of the policies. I don't know about India, I don't know about Bangladesh, I don't know about some of the other countries, but I do know that in all of these countries I've seen lots of contaminants and lots of waste. And one example also is if you see air pollution in New Delhi, for example, people still drive, and you see motor vehicles and old vehicles emitting lots of fumes, for instance. We have to get our vehicles checked every so often, and they check for fumes as well.
Thank you, sir. There is one more question from Dr. Keshav. Professor, what are the protocols, concepts followed in Australia and CRC to conduct the risk assessment of a mixture of toxicants?
Pardon me.
What are the protocols, concepts followed in Australia and CRC to conduct the risk assessment of a mixture of toxicants at a local level as seen in the environment?
Again, very, very good question, because no matter which country we go to, the focus is always single contaminant. People really look at mixtures. And right now, I know in US, I know in Australia, we are starting to work with mixtures to see whether mixtures enhance risk or mitigate risk. So that's something which we do.
Hello. Hello.
Okay, again, everybody knows that mixtures do alter risk, and we did work on health screening levels for petroleum hydrocarbons, where we took into consideration mixtures showing that depending on what contaminant constituent we had, risk could vary quite a lot. So Australia is now beginning to look at mixtures, and it will be many years before we'll come up with guidance on that.
Yes, sir. Thank you, sir. There is one more question from Kiran Kumar. Professor, can you please brief how effective current soil cleanup technologies are and an insight into future technologies?
Very good question, Dr. Kumar. It very much depends on whether we are looking at a high.
Hello.
Sir, I think Professor was removed.
What happened?
Oh,
He's back.
Sorry for the trouble, folks.
No. It very much depends, Dr. Kumar, on whether we are looking at highly contaminated site or diffuse contamination such as farms. Let's just look at farms, for instance. If you look at farms, for instance, we have low dose of cadmium from superphosphate fertilizer. We cannot remove the soil. We cannot extract metal pollutant from the soil because the area is large, volume of soil is very large. So what we do is we take a risk-based approach. I'll give an example of a risk-based approach. Let's say that you go into forest and you are the receptor and there are lines. Lines can grab you and you are gone. And risk-based approach is, why don't we put a barrier between the line and yourself, your receptor, and the line is the fraction of contaminant that is free to impact you. So if you put a barrier, you are minimizing the risk that contaminant poses to you. So in agricultural soils, for example, the barrier is knowing that pH controls chemistry of metals. So if you raise the pH to somewhere between 6 to 6.57, cadmium is bound to soil, and therefore the fraction of cadmium that's available for uptake by plant decreases, and that's what we use globally in farm soils, which is different, for example, for highly contaminated site. Even highly contaminated sites, you cannot extract metal cadmium. Often you immobilize it, and here we immobilize it using other agents, and either you leave it there or it's taken to prescribed landfills. Hydrocarbon contamination is different because you can enhance natural attenuation, get the bugs to work, do the work, unless it's a persistent pollutant, in which case you look at other means of managing that. So that's I'll be happy to discuss with you outside this as well, because there are so many other things that we can do.
Thank you, sir. One question from Ajay. Sir, could you please suggest some hints on the visible indicators of soil degradation or contamination due to chemical pollution?
So you're asking really good questions, and more often, for example, when I go to regulatory jurisdictions or when I talk to industry people, I would take two bags. One bag will have contaminated soil, the other will be uncontaminated soil. I'll have two bottles of water, one contaminated and the other is not contaminated. And contaminants that don't give color. And also two bottles of water where you see color as well. So I said to these people, have a look at these two bags of soil. Which one do you think is contaminated? They can't distinguish between the two. How about water? They can't until such time I have chrome in water and you see a color change. So what I try to point out to them is that more often you do not see contaminants that are present in soil, but long-term impact is what we feel afterwards, after a long time. And therefore, low doses of contaminants, it's hard to see pollutants, but if you have very high dose, for example, it impacts through toxicity of plants, you can start to see plant degradation. And then we say, well, what has been the reason for this? And we then relate that to pollutants present. Unless we are looking at organic contaminants, if you have high levels of organic contaminants, you actually see that in the soil as well. So coming back, Director, sir, it's not easy to just visually delineate soil contamination, contaminated soil from uncontaminated soil, because it's hardly visible. But we can use certain tools to look for the presence of certain contaminants.
Thank you, sir. One question from Dr. Krishna Kumar. It's interesting to hear that there is always a tendency to cover up contaminations. So suppose if the source of contamination is from a government agency, how can we address it?
There are many government agencies that could be linked to contaminated sites. For example, when you look at Indian Defence as an example, the shooting range where they try to shoot and practice, for instance, you would have lead bullets, and that will be highly contaminated site, for instance. There will be other industries as well. It's a lot of effort. Defense is always very, very good. They're all about sustainability of the environment. It's all about homeland security as well. And therefore, they are pretty good discussing and also working with you jointly. I found that really great. But the important thing is to bring together mining companies, for example, manufacturing industries, and get them to see the impact of pollutants on the environment. They are all about sustainable development goals. See whether they can take that on board and see whether they can contribute. In Australia, for example, the CRC care that I have, it's 100% supported by industry and defense. In the absence of their contributions, CRCK wouldn't be where it is today. And therefore, one thing we can do is to bring together under an umbrella that, like we are doing in Malaysia now. Malaysian government has asked us to establish a node of CRC care, and our task is to see how we can get the industries, and money will be spent in Malaysia, but our task is to how we can get the industries to come together and how we can train people, and those trained people, how they can go back and start helping them clean up the environment. So the key is to see how we can create awareness, visibility of the need to the, I say end users, and end users being private companies and government departments, and for them to invest, but also for them to recognize that it's all about future generations.
Thank you, sir. Participants, any more questions? So I think no more questions. So to conclude with, may I now request Pratish, a senior scientist, CSIR-NIIST, to deliver. Over to you, sir.
Good afternoon, Professor.
So you're muted.
Okay. Am I audible now?
Yes, sir.
Yes.
Okay. First of all, I would like to thank Professor Ravi Naidu for kindly accepting our invitation and delivering such a very insightful and thought-provoking lecture.
Pradesh, you can
Yes.
move a little bit towards camera because you are not visible completely.
Yes.
Yeah, now.
Yes.
Yeah, no problem.
Yeah.
Okay. No.
So we are indeed extremely grateful for you for delivering such a wonderful lecture. And it's many of the points or factors which you have emphasized throughout your lecture is extremely relevant for our country, and we need to address many of those issues in future. So and as you all, many of you us may not be knowing much about Professor Ravi Naidu. He has as a small Indian connection also. He was his forefathers was his grandfather was an Indian, and they were deported or they left India to Fiji for sugarcane farming and so on. And his career is such an inspiring, and life is such an inspiring one, which has gone through several hardships throughout his life and to achieve such a wonderful career. And moreover,
Sir, you're muted. Please.
oh, okay, there is some problem in the system. Okay, so now,
Sir, please unmute.
am I audible now?
Yeah, proceed, sir.
Okay, so we on behalf of CSIR, I don't know. I'm getting out. I mean, somehow it is.
Yeah, you can proceed, sir.
Yeah. Okay. So on behalf of CSIR-NIIST, I would like to thank profoundly Professor Ravi Naidu for delivering such a wonderful lecture. And also we would like to collab, as mentioned, we would like to initiative for international network on soil pollution, and we would like to be. Unfortunately, I'm in between. I'm getting out of the network. Professor, am I audible?
Yes, sir.
Yes, Pradesh.
Yes. Oh, okay.
Yeah, very much.
Okay. So, we, as the Environment Technology Division, we would like to collaborate with you in the future for such major global initiatives, and we also thank you for your such great initiatives. Our director, I would also like to thank our director, Dr. Ajay Ghosh, for encouraging us to take up this activity to conduct such an environment day lecture and invite a very distinguished participant speaker for inaugurating this session and giving the keynote address. And I would also like to thank our IT lab, especially Mr. Reuben Jones for his organizing this or arranging all the network facilities for arranging the organizing meeting. And also finally, I would like to thank our colleagues and students and technical staff who have participated and asked very valuable questions throughout the this lecture. So with that, I would like to once again thank Professor for joining us and giving a very informative and insightful lecture on the occasion of.
Thank you very much, Dr. Prasid. Can I thank you first for inviting me? If it wasn't for you, I wouldn't be here today with you. And of course, it has been very educational for me as well. Thank you so much.